In this video, I'd like to talk about word problems with the Pythagorean theorem. So, in this problem, Santos walks 2 kilometers south. So he starts here, he walks south 2 kilometers, and then a certain number of kilometers east. So it looks like this is what we're trying to find. And he ends 5 kilometers away from his starting position. So here is where he ended, and here's where he started, and they're telling us that this distance is 5 kilometers. So how many kilometers east did Santos walk? So, like I said, this is the quantity we need to figure out. So once he made this turn, he went south 2 kilometers and then east a certain amount of kilometers. This turn is at a 90-degree angle, since he was going due south and then he's going due east. So we have a right triangle here. And the Pythagorean theorem relates the sides in a right triangle. So let me draw a quick sketch of that. So let's say we have some right triangle and we know the side lengths. We can call these A, B, and C, and this is a right triangle. Then the Pythagorean theorem, the relationship between these sides is that a squared plus b squared is equal to c squared. So we square each of the sides, we add them together, and they're equal to the hypotenuse, which we call c squared. Remember, the hypotenuse, that's the long side that is opposite our right angle. So we want to use this theorem to answer questions about right triangles. And since we know we have a right triangle, we can just set up essentially this relationship between these three side lengths. So the main idea with using this theorem here is that A and B, these are the legs of the triangle. They are next to the right angle. And C, that's the long side. That's the side opposite the right angle. So we can call these A and B, and it doesn't matter which we call which. So if we call that one A, then this one will be B. And from here, we can just set up our equation. So we have that a squared, that's x squared, plus b squared, that's 2 squared, is equal to c squared. And c in this case is 5, so this is equal to 5 squared. So from here, we just want to solve for x. So let's simplify first. Since 2 squared, that's just 2 times 2, that's 4. 5 squared, 5 times 5, that's 25. And we'll subtract 4 on each side so that we get x squared is 21. Now to cancel out that square, we need to take a square root of each side. And when we take a square root of a square, they cancel, so we just get x. And usually we would put plus or minus when taking a square root of each side, but because we're only concerned with a physical distance, we only care about the positive case. So we just have the square root of 21, which is not a whole number, since 21 is not a perfect square. In fact, 21, or the square root of 21, that's between the square root of 16 and the square root of 25. And we know the square root of 16 is just 4, and the square root of 25 is 5. So the square root of 21 is actually an irrational number. So we'll have to use a calculator to round this number. And once you plug this into your calculator, you can see that the square root of 21 is equal to 4.58257, and it's going to go on forever. So your calculator will round it at some point, so it might not look like it's going to go on forever, but this is an irrational number. So it has an infinitely long decimal without a pattern. So we just want to round this to the nearest tenth of a kilometer. So we can say that the square root of 21, or x, is approximately, so we're rounding it to the tenths place, so we can round this up since the next number is an 8. So this becomes 4.6, or approximately 4.6.